Well, hello, Algebrainiacs. Welcome to the Johnson-Kendra Video Hour.
But it's not an hour.
Alrighty, well, one of these days we'll promise you we'll make it an hour, but not today. Alright, today we're going to talk about Chapter 7, Exponential Models. So each model is in the form y equals ab to the x.
X is a variable that's an exponent now.
Yeah,
We've
so
never
it
had
makes
that
some
before.
funky graphs. Now it does have some stipulations here. X has to be a real number, A can't be 0, and B can't be 1. Alright, next thing, B is the growth factor or decay. So you're either going to get more or get less with B, and A is the initial amount you might start with. Now there are two kinds. There's exponential growth. That's where the B is greater than 1. So let's try one. Alright, here's our equation. Y equals 4, 2 to the x. So we're going to pick a bunch of numbers, and we're going to put them in for x. So I need to put negative 3 in right there.
Now this negative 3 to 3 is a good place to start, but some of these numbers end up too small to put on the graph or too big to put on the graph, but it's kind of just a good general, yeah.
So 2 to the negative 3. Now with a negative exponent, you have to put it in the basement.
He's unhappy, he goes to the bottom.
But the 4 doesn't have an exponent, so it stays right where it is. So this becomes 4 over 2 to the third.
2 to the third is 8.
So 4/8 is really
1 half.
Alright, then we have to do negative 2. Let's get rid of this. So 4 to the 2 to the negative 2, that'd be 4 over 2 squared.
So 4 over 4 is 1.
Yay. Alright, keep moving.
This time 2 is going to the bottom.
Whoops. 4 over 2 to the positive 1, that's 4 over 2.
Hey, I noticed something here. They're all doubling.
What's happening? That may be what's going on with this number right here. Let's see if it happens again.
Okay, 2 to the 0 is 1.
So 4 over 1 is just 4. Oh, it doubled again.
Okay.
Think it's going to do it one more time? Now this time I don't have to put it in the basement.
How come?
Because it's positive 1.
Oh,
so
gotcha,
4
gotcha.
times 2 to the 1 is 8. Hey, it doubled again.
So I bet the next one is 16.
We'll see. 2 squared times 4.
That's 4 times 4 is 16.
Right, and I'm just going to go out on a limb and say this is 32.
Yeah. And I bet these are a little too big for your graph.
Yep, so we'll just go
okay.
with the other ones.
Got to know the general shape.
Alright, so negative 3 1/2 is about here. Negative 2 1 is here. Negative 1 2 0 4 1 8.
Wow, that increases really quickly.
Yeah, so our graph is going to look like that. Alright, then make sure we put arrows on both sides here to show that it goes in both directions forever.
Alright. That's always the general shape of an exponential growth graph. It always looks like this. So if you were to keep going with numbers that are smaller than negative 3, this thing's going to keep getting smaller and smaller and smaller and smaller and smaller because essentially when you're moving to the left, it's cutting in half. So if you keep cutting something in half and half and half and half and half, does it ever actually get to 0?
No.
So that means that this can't ever touch the x-axis. That's called an asymptote.
So it's kind of like the boundary.
Right.
It never goes past it.
So the horizontal asymptote that we have here is y equals 0.
Huh.
And what that means is this, it's kind of hard to show with our smartboard graph, but this just keeps getting smaller, 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 forever and ever and ever.
Never quite gets there. Think of taking a piece of paper and cutting it in half. You can always have a little bit more to cut in half. So it never gets to nothing.
Yeah, eventually we'd need a microscope to cut it, but...
Very, very tiny scissors.
Yeah. Okay, exponential decay.
Alright, let's try another one here.
So this is different. It's the same equation, but it's different because the b is smaller than 1, and it's a decimal here, but maybe for our exponent purposes it might be helpful to change it to a fraction.
Yeah, fractions are a little friendlier than decimals sometimes.
I don't know if our kids would say that, but I think so.
Yeah, when you have to do things by hand, they are.
Okay.
Alright, so a decay means our graph is probably going to go smaller. It's going to fall instead of rise. So we'll see if that happens. So I have 2 to the 1/2 to the negative 3. So I'm putting this negative 3 in right now. So I have 2 over 1/2 to the third. 1/2 times 1/2 times 1/2 is 1/8. But to actually work this out, we flip it over and multiply, so we get 2 times the 8 over 1.
So wait a second. That negative exponent that you had just flips the fraction over, right?
Yeah, we could do that too.
Yeah.
You could do a shortcut now that we see that that works. Okay, so let's try another one with a negative.
I like that little tricky too.
I like that too. So 2 to the 1/2 to the negative 2. So that really
flips the 1/2.
So it's 2 to the 2 to the 2.
2 to the 2
Like
is...
I'm in ballet class with my 2 2s. Or 3 2s here. So 2 times 4 is 8. Look at that. What's happening
Cutting
now?
in half.
So this number kind of tells you what's going on.
That's the decay factor.
So it's getting smaller by a half every time. So I'm going to just go out on a limb here and say that's going to be 4. That's going to be 2. Cut that in half as 1. Cut it in half again. Cut it in half again. So those are all my answers.
All right.
All right, if you want to test those, feel free, but we're going to just go with it. This looks a little too big, and, well, we'll try the other one.
1/4 might be too small.
So negative 2, 8 is here. Negative 1, 4. 0, 2. 1, 1. 2, 1/2.
That's good.
3, 1/4. I don't think I can get that to look with my big dots. So here, the graph keeps going that way. And once again, we have a boundary here.
Called a horizontal asymptote.
Right.
At
so
y equals 0.
Y equals 0 is our horizontal asymptote.
I want to point out another feature of the graph. This was a decay graph. This was the decay factor, but this was the starting amount, and if you look, this number, your A value, is always going to be the y-intercept.
Oh, good observation.
Yeah, and the same thing with our growth. So here we had a growth factor of 2 because it was bigger than 1, and the starting amount should be 4, and if you look, that's your y-intercept. So that's kind of a good way to check your answers.
Yeah, they might ask about that in problems too.
All right, so that's the first concept, the graphing. But we also need to talk about where the exponential stuff applies to real world
Because
things.
it is used out there
Yeah,
in a lot of different
lot.
places.
All right, so remember the equation is y equals ab to the x power, and b is the growth or decay factor. So when we're talking about population growth, what you'll have to do is add your growth percentage to 1. And some of us have a hard time understanding why, but if you think about this, this 1 represents 100%. For instance, let's say we're going to buy a sweater.
Yay, like sweaters.
Yeah, let's say the sweater costs $10. It's a cheap sweater. But when you go to the counter, you pay more than $10 because of sales tax.
6%.
Right, so what you do is you pay 100% of the price plus the 6% sales tax, which is 106% of the original price.
Aha.
So you end up paying $10.60.
So do you add 106 to 10?
No, you would multiply the decimal.
Oh, it's percent, so you have to make it,
Right.
move your decimal 2 places.
2 spots over is 1.06. You multiply that by the starting amount to get our 160.
Because that'd be a lot of money
Yeah.
for tax,
Yeah.
$100.
Okay, so kind of went on a tangent there, but your growth factor, this is 1 because that is 100% as a decimal, plus your rate of increase, and again, that needs to be as a decimal.
All right.
For your B value. So here's the situation. The U.S. population in the year 2000 was 281 million, and the rate of increase was 1.24%. So even though that's a decimal already, that's still a percentage.
So you got to move your decimal place 2
spots. So it's going to
Okay.
be 0.0124. That looks like a
So
comma.
that's our R.
That's our R.
R. We're laughing, but not at you. We're laughing at ourselves.
I thought we were pirates.
Oh, R.
If the rate of increase stays consistent, write an equation to model the growth after the year 2000. So remember that the exponential growth equation is this. A always represents your starting amount, and they tell us that right in the paragraph there. It's 281 million. Okay, now the B is going going to be equal to 1 plus your rate of increase. So that is 1 plus 0.0124 because we changed that percentage to a decimal. That is 1.0124
That's
to the
easy.
x power. This would represent our equation, and the x would represent how many years have passed since the year 2000.
So if I wanted to figure out my population in 2008, I would put
An
an
8.
because that's how many years past 2000.
Right.
Oh,
And make sure you do your exponents before you do your multiplication.
oh
So
yes.
do this to
Follow
the
your
power
order.
first.
Yep.
Yep.
Order of operations is still in effect.
All right. Let's say something crazy happens and we get the plague going
Oh,
in the year 2000.
N121 or what's that flu? I don't know what it is, but it's
H1N1.
H1N1. N121. R2D2. It's all the same.
What if you were writing an equation for population decrease of 3.2%? So remember that when it was growth, we took the 100% and we added the rate. If you have a decay, you got to take 100% and subtract the rate.
Okay.
So that gets a little tricky because kids will just put in the parentheses that the percentage is 0.032.
But it's 1 minus that.
Right. Right.
Okay.
Yep. So
all right.
be aware. Oh, we got one little more thing.
All right, we gotta just take a little quick look here. We gotta decide, is this an increase or a decrease? So you just see how it compares to the number 1. Is it more than 1 or is it less than 1?
It's definitely more than 1.
So that means we're increasing. That
Yep.
means I would have had to add 1 plus 0.37, so that's an increase.
So 0.37, and that would imply a 37% increase.
Aha.
All right.
All right, well now we compare it to 1. Is it more or less?
It's less.
So we do 1 minus 0.85.
1 minus
or something.
Is
0.15.
That's what it's decreasing by.
Right. So you kind of do it backwards to
Yeah.
figure out what it is.
You're thinking how many more than 100% or how many less than 100% it is.
Yep. So it's not just that number in there.
Okay, here's the challenge.
Oh my. How much more than 1 is it?
That is, so in your head you can be thinking 3.02 minus 1
So
is
2.02,
2.02, which as a percentage is
202%.
And so obviously that is an increase.
Yeah, big time.
All right.
All right, good
That's
job.
it.
Ta-ta for now.
See you guys.